do a quick overview of the Kubernetes Secret Manager. With this tool, you'll be able to request dynamic secrets from a MySQL database. Those usernames and passwords that you request will come from Vault. Vault's a tool from HashiCorp, which will let you request dynamic secrets and put a TTL, a time to live, on those usernames and passwords. You can also put a max TTL on those credentials and enforce rotation of those credentials. So the goal of this is to implement that scenario there, where we can request dynamic credentials from MySQL, and we renew leases on an interval, and we're forced to rotate them. Now what we're going to do is we're going to show how this tool here will auto-rotate those passwords for you and drop them into a pod via Kubernetes secrets. This will all be managed for you automatically. Cool, let's do a quick demo. Before we do the demo, I just want to give a quick shout out to Kelsey Hightower for his help and insight and guidance on this. Also, this is inspired by his Kubernetes cert manager project, which he wrote, which does a similar concept, but it fronts certs via a Let's Encrypt API. So again, big thanks to him for all his help with this. Cool, let's go ahead and deploy. So what you can see, I have in my cluster, I have no pods, I have no services, and I have no secrets. Right, so we're clean. So let's go ahead and deploy some things. So let's go ahead and create our MySQL deployment, and we'll create our Vault deployment as well. Now these are both in a developer mode. This is not, there's no data persistence. This is not a production-ready type deployment. So this is just the proof of concept. So what we can do is we can see our pods. Those are up and running. Let's go ahead and configure Vault. So now you'll see out in the README, we have a deployment guide, which walks you through how to do this. What we want to do is we want to deploy the MySQL backend, so Vault knows how to set up credentials to MySQL. So we've included a script in the Vault image that you download, and what it's called Setup Vault. And what this is going to go do is create a custom backend, which creates two roles. There's a read-only role, and there's a full access role. And with these two different roles, we'll be able to request read-only credentials and read-write credentials from Vault, which will then return those from MySQL. Cool? Great. Now with that written, we need to go deploy our custom controller. So what first thing we have to do is go ahead and grab our Vault key. So we're going to logs our Vault server and grab our root token. Again, this is running in dev mode, so it's already unsealed. It's already good to go for us. So I grabbed that. Let's hop over to our deployment and let's update our Vault token. Cool. And we'll go deploy that. Okay. So let's get a pod, see if that comes up. Great. So now our secret manager is running. So now let's go deploy our sample app. And what this is going to do is going to create a custom third-party resource. Which is called Custom Secrets. Now within this, we're going to have get custom secrets. Now we have that, we can create our read-only secret and our read-write secret. And what we've defined in this secret is for the read-only, we're going to request the read-only role from Vault, and we're going to deploy that into Kubernetes called DB read-only credentials. Similarly, we're going to request for the read-write custom secret, we're going to request the full access role from Vault, and this time we're going to deploy that into a DB full credentials Kubernetes secret. What we have is our sample app is going to read these kube secrets, which will be populated by this controller automatically. So let's see if our sample app came up. It's up and running. Let's go ahead and look at our secrets. And here you can see we have those DB full credentials and DB read-only credentials. Let's take a look at those and see how those work. And what you see here is your username and password field. Now in here we're going to pull out. Let's take a look at that password. So this is base64 encoded, so let's go ahead and decode it. there's our password, and let's grab our username. There's your username. So let's go ahead and let's test these out. Let's go to MySQL Workbench, and let's edit a connection to Minikube. And let's grab our username, which is this guy. And then we'll paste that in, hit close. And let's grab our password, which is this. And we'll connect with that same credential. Oh, I forgot to make my tunnel. So we'll go ahead and grab our pod. Now what it is, I'm going to port forward the MySQL container in 13306 to 3306. It's spelled kube control. There we go. So now we're going to just copy this password again. Hop back to our workbench. And now it's prompting us. We'll paste the password. Cool. And now we're in. And just to prove that we can write, because this is a read-write credential, we can say create table. We'll call it table foo. And we'll say apply and apply. Cool, and we created that. So now we have a table here created, right? In the same sense, we can do that with the read-only rule. Let's just prove that. Let's hop over to here, get secret, db read-only, and we'll output that to YAML. And let's do the same exact thing again real quick. So we'll echo that, base64, decode. And we'll do the same thing with this. Great. So now let's go back to MySQL, and we'll edit this connection. And this time, instead of the full access, we'll use the read-only user. Paste that. And let's go grab our password. Our tunnel's still up, our port forward, so we're cool there. We'll paste that. Great. Now we can read only. And now if I try and drop that table foo we created before, drop table, drop now. It's going to deny my access, right? Because I don't have access to do that because we're read only. Great. Cool. So now let's take a look at our sample app. Here's our services, and let's describe our service sample app. Let's grab the node port, which is this guy. And let's hop out here, and we'll open up a new thing, and we'll say Minikube, the right port. So here's the app we're doing, and here's those root credentials we use again. This root full, for the read write, so full root access was this one. Now, if we look at our service, we can see what's happening behind the scenes is with those two credentials, we are pushing that TTL forward. We're renewing that lease, right? So there's a 1 minute interval by default, just for the sample, or 1 minute duration on the lease. When the lease hits around half, we're going to renew that lease, and this is to help manage when the lease expires. The credentials we get have a maximum right now of 10 minutes, right? So these credentials, no matter what, will only be good for 10 minutes, assuming we're renewing the lease correctly. At the end of 10 minutes, before that, what we want to do, we want to rotate those credentials. So we're going to go request new credentials from Vault, and we're going to swap those out dynamically. So what we can do is leave this up, this user, and as soon as those credentials expire, we will refresh this page and we'll see how the pod gets updated with those new credentials. So here we'll fast forward till the end to kill the time. There it is. Cool, thank you much. Come check me out on Twitter. Check out our GitHub profile. Any questions, please post them there. Thanks.